Hey guys, Mr. B here. I almost forgot my own name. Gonna give you guys a little finding the exact roots example, and if you remember from what I mentioned in class, this is typically the first long answer question on your public exam. So it might be a good idea just to make sure that you've mastered this outcome, build a little bit of momentum for the long answer questions, and build a little bit of confidence towards the last 50 marks of your exam. So this is a typical problem that you might see on your public. And the idea, usually with the exact roots, is to use the quadratic formula. So before we do that, we have to get the quadratic into general form. So you see here we sort of have an x outside the bracket. So usually when you have something like that, you have to distribute. So let's distribute through here, just like that. So x times x is x squared. And x times negative 2, that's negative 2x, and this is still equal to negative 3. And then we have to bring this across, or add 3 to both sides. So we always have to have, in order to use quadratic formula, we have to have one side equal to 0. So if you were on a public exam, to get to here it might be worth 1 mark. So never think that just because I can't use the quadratic formula or forget or whatever the situation is, always try, work it down and see what, if this is worth 4 marks and this would be worth 1. So that's something, it's better than nothing. Alrighty, so let's have a look at using the quadratic formula on this guy. So if you remember, this guy's A, B, and C, and the quadratic formula looks like this. X is equal to, make sure you write this part, negative B plus or minus the square root b squared minus 4ac. Remember this guy, b squared minus 4ac, called the discriminant, all over 2a. So now it's just a matter of filling in the blanks here. So let me extend my page a little bit here. So b is negative 2, so negative b, that means it's going to be positive 2 or negative negative 2. Actually, I ought to write that in there just to. So negative negative 2, which will be positive 2, plus or minus negative 2 squared minus 4. A is 1. It's not written there. So A is actually right here, 1. C is 3. All over 2 times 1. So let's just do the math on this guy. So inside the brackets here, so we got a positive 2 right here now, like I explained. Negative negative 2 is a positive 2. And then I have 4, and then 4 times 3 is 12. So it looks like I'm going to have a negative underneath my root sign. I'll explain what that means. You should remember. And then I have 2 plus or minus. Now 4 minus 12 is going to be negative 8. So what that means is, because I have a negative underneath my square root sign, it means I'm going to have imaginary roots. So what you need to remember for imaginary roots is that the square root of negative 1 is equal to I. Alright? So what that means for us is, all I think of it is, if this is negative 8, well, that's the same as negative 1, or root negative 1, times root of 8. Or you can think of it even like this, negative 1 times 8. All underneath the square root sign, then that breaks up even further. Or, since that's just I root 8. Anytime I see this in a problem, this is how I know I can do it, the understanding behind it. But all I got to do really is, this is negative 8, get rid of the negative and put an I out front. So make it look like this right away. Plus or minus I root 8 all over 2. So I got rid of the negative and put an I outside the root sign. Now this is not exactly reduced, so we need it in the simplest form. So root 8, well, 4 times 2 is 8. So this breaks up into 4 times 2. This might not be a step that you do. Divided by 2. Now the square root of 4 is 2, so what I'm left with is 2 plus or minus 2I root 2 all over 2. And then that reduces down to, this 2 has to go to both things. So it has to go to So 2 divided by 2 is 1 plus or minus I root 2. And there's my final answer. Hopefully I never made any mistakes in there. But that's what your final answer looks like. And always a good idea on your public exam, box it out. Now these are going to be a little bit harder to check when the I is involved. What you might want to do is just simply have a look at the discriminant again and make sure that you run that and you check it. If you have a graphing calculator, you can graph this guy and make sure that it's not touching the roots of the x-axis. Anything with imaginary roots is either going to look like this or like this. There's going to be no contact with the x-axis here. Alright, that means that the discriminant b squared minus 4ac is less than 0. Alright, so anytime that's the case, that's what you kind of should know. Alright, let's have a look at a little bit of a different example. That one's a little bit easier to organize and get your general form. Well, this one's a little bit harder. So you got 5 divided by x minus 3 is equal to x divided by x plus 1. So there's actually a couple restrictions here that we should note. X cannot be 3, because if you have 3 subtract 3, you'd have 0. And x cannot be negative 1. So chances are that won't be the case, but you never know. So always a good idea to check at the end or just keep it in mind at the beginning. So whenever you have a situation like this, when you basically have two rational expressions equal to each other with no plus 1 or plus something else, maybe it's plus x or plus or x over x minus 5, whatever, something. It's just two rational expressions, two fraction looking like things equal to each other. Then you can simply cross multiply. It's very similar to when you did proportions back in like grade 9. You had something like this and you cross multiplied in order to solve it. So you went 1 times 4 x times 2. But as soon as you throw in the plus 1 here, you can't use cross multiplication anymore. You have to do some simplification first, or you can multiply through by a common denominator, which is what we would do if you had a rational expression, another rational expression added on here. So what we're going to do is we're going to cross multiply. So we're going to go 5 times x plus 1. 5 times x plus 1 is equal to x times x minus 3. And then we're just going to distribute through here. So 5x plus 5 is equal to x squared minus 3x. So you should always end up with an x squared with these type of problems. If you don't, chances are you did something wrong. We're most likely going to be solving quadratics, so you need a quadratic. So I usually like to have my x squared to be positive. So I'm just going to take everything over here, bring it across, change the sign. So x squared, and then I'm going to take negative 5x minus 3x. That's going to reduce in my next step. Minus 5 is equal to 0. So I took everything over here and brought it across. Then I'm left with x squared minus 8x minus 5 is equal to 0. Again, you don't necessarily have to have that, but this is just the way I do. You avoid having a negative in the denominator of the quadratic formula like that. So it makes life a little bit easier. You always want to maybe double check, but yeah, that might be worth a little bit more than 1 mark there. That might be worth 1.5 or even 2. So make sure you get it right here before you go ahead and do all your stuff. But I'm going to ignore my own advice here and just simply fly through this. So hopefully I don't make a mistake. So again, A is 1, B is negative 8, C is negative 5. So this is going to be 8 plus or minus. Remember, it's negative B, so if this is a negative 8, just negative 8, which is positive 8. Then I have negative 8 squared minus 4a, which is 1. C, which is negative 5. So I'm going to have a positive number this time. Anytime one of these numbers is A or C, C is negative, because for me A is always going to be positive, but anytime C is negative, you're going to have basically a positive underneath here. Then 2 times 1. 8 plus or minus 8 squared is 64 plus 20 all over 2. 8 plus or minus, that's going to be 84 divided by 2. So then you got a situation here, you got to try and reduce this guy. So I'm looking at that, it's not blatantly obvious to me what it's divisible by. Perhaps 16. Let's have a look. Break out my calculator. So 84 divided by 16 No good. Let's try 4, simply 4. So we're clear on this guy. Here we go. 84 divided by 4. 4 is going to work, of course it will. 21. Okay, we're good. Alright, so let's see. 4 times 21 divided by 2. And then 8 plus or minus 2 root 21 divided by 2. Make sure that guy goes all the way across there. And then again, this divides into both. So if one of these numbers is not divisible by 2, then you can't do anything. But if they both are, then we're good to go. So 8 divides into that 4 times, or sorry, 2 divides into 8 4 times, plus or minus root 21. And that's it. We're good to go. So again, you might want to check by graphing this guy. And there's a function on your graphing calculator. You can find the roots, and then you get decimal approximations of the roots. Then you can just decimal approximate this guy and see what you get. Alright guys, this is something that you guys were good at when we did it throughout the unit. So hopefully it makes sense. I'll see you in class.